Hello students, in our previous classes we have learned about what is solution, after that types of solution, and then concentration of solution, and after that numericals related to concentration of solution. And in today's class we will learn about solubility of a solution or simply solubility. Okay? Suppose I have a solvent in which I am dissolving a solute, okay, to prepare a solution. I have a solvent, and in the solvent I am dissolving a solute, a particular solute, to prepare a solution. If I notice, at first the solute will dissolve quickly in the solvent, and after some time the rate of dissolution will decrease, and after a point I will observe that, or you will observe that the solute will not dissolve in the solvent. So that means in a particular solvent a maximum amount of solute can be dissolved. After that amount or after that limit, whether if you add the solute will not dissolve. So that means we can say that in a particular amount of solvent always a maximum amount of solute can be dissolved at a particular temperature, and that maximum amount is known as solubility of that solvent or solubility of that solution. Okay, this is the definition for solubility of a solution, or this is the basic concept of solubility of a solution. Okay, now we have to see the factors affecting solubility of a solution, or the factors affecting solubility. I already mentioned that solubility is the maximum amount of solute dissolved in a particular solvent at a particular temperature. So that means temperature has effect on solubility. Therefore the first factor is temperature. Okay. The next, second factor, nature of solute and solvent. If the solvent is water, and the solute is sodium chloride, then sodium chloride will easily dissolve in water. But suppose the solute is an organic compound, suppose it is methane, a hydrocarbon, methane gas, okay, then it will not dissolve in water. So that means polar solutes are, or ionic solutes are soluble in polar solvent like water, but non-polar solutes are insoluble in polar solvents like water, but they are soluble in organic solvents like benzene, carbon tetrachloride, okay, ethanol, etc. So that means we can say that the next factor which affect the solubility is nature of solute and solvent. And after that, the next factor on which solubility depends is pressure. Okay, pressure has also effect on solubility. So therefore we can say that there are mainly three factors which affect solubility of a solute in a solvent. Okay, and they are temperature, after that nature of solute and solvent, and after that pressure. And when we will learn about solubility of solid in liquid, solubility of gas in liquid, then we will study them in detail. Okay, now we will study solubility of solid in liquid. In this case, the solid behave as solute and the liquid is solvent. Okay, again I can take example of this solution. So that means water and sodium chloride. We have added sodium chloride in water. When sodium chloride is added in water, so at first the sodium chloride will dissolve in water and they will form Na positive and Cl negative ions. So that means the sodium chloride will dissociate it to their constituent ions, and this phenomenon is known as dissolution. So at first dissolution will occur, and again the Na positive and Cl negative ions can combine to give back the sodium chloride, and the reverse process is known as crystallization. Okay, suppose now I am adding sodium chloride continuously to water. Then I already told you that, and this water will dissolve a maximum amount of sodium chloride, and that amount is known as solubility of this particular solution. Okay, so that means the maximum amount of solute that can be dissolved in a particular amount of solution, so that is known as solubility, and at solubility the solution is known as saturated solution. Okay, so at first I am adding sodium chloride. At first dissolution will occur, after that crystallization will also occur, but rate of dissolution is fast as compared to crystallization. So therefore what will happen? Sodium chloride will dissolve or disappear in the solution. Okay, but when the saturated solution is formed, then the rate of dissolution and rate of crystallization will be equal. Okay, and equilibrium is established when both the forward process and backward process have same rate. Then an equilibrium will establish, and that equilibrium is known as dynamic equilibrium. So therefore we can say that at first dissolution occur, after that crystallization will occur. Okay, after that saturated solution will form, and in case of saturated solution the rate of crystallization and rate of dissolution both are equal, and an equilibrium is established. That equilibrium is known as dynamic equilibrium. Dynamic equilibrium. Okay, so we can say that when a solid is dissolved in a particular solvent, then at first the solid solute will dissociate and goes to the solution, and this process is known as dissolution. Okay, and then some of the dissociated ions or solute may combine with each other to give back the solute, and this is known as crystallization. Initially the rate of dissolution is fast as compared to rate of crystallization, therefore we will not observe the crystallization as compared to dissolution, we will only observe dissolution. But when the saturated solution is formed, when maximum amount of solute is dissolved in the solvent, or when the saturated solution is formed, then the rate of dissolution and rate of crystallization both will be equal, and an equilibrium is established. That equilibrium is known as dynamic equilibrium. Okay, these are the main concept of solubility of solid in liquid. So after that we will see how those factors which affect solubility of solid in liquid. Those factor means temperature, pressure, nature of solute and solvent. Okay, so therefore our next heading is factors affecting solubility of solid in liquid. Factors affecting solubility of solid in liquid. The first factor was nature of solute and solvent. And we already know that ionic compounds are soluble in polar solvent like water, but they are insoluble in organic solvents. Again, non-ionic compounds or non-polar compounds are, but non-polar solutes are soluble in organic solvents, but insoluble in water. And the next factor is temperature. Okay. So here there will be two cases. The first case, when dissolution process is exothermic. When dissolution process is exothermic. Okay, so that means when we add solute with the solvent, okay, dynamic equilibrium will establish and the solution will obtain. And along with the solution, the process is exothermic, heat will evolve. In case of exothermic processes, heat is evolved along with the product. So here the product is solution, we have added solute and solvent, and the product is solution, the solution will obtain. Along with the solution, heat will evolve. Okay, practically we can take example. When you add concentrated sulfuric acid with water, a solution will obtain and the container will be heated up. So that means the temperature of the container in which the solution will form will rise. So that means heat is evolved in that case. So in this case, exothermic, therefore heat is evolved in this process. Now if we increase the temperature, we will supply heat. And according to Le Chatelier's principle, the dissolution of the solute in the solvent decreases because the equilibrium shift from right to left. So that means the solubility of a solute in a solvent decreases when the dissolution process is exothermic. So we can explain this according to Le Chatelier's principle, which you have already studied in class 11. Case 2. When the dissolution process is endothermic. When the dissolution process is endothermic. In this case, we have to apply heat during the formation of the solution. Endothermic, therefore in this case heat will absorb. We have to apply heat along with the solute and solvent to get the solution. And in this case, when we will increase the temperature, we will supply heat. Okay, so that means the equilibrium will shift from left to right and the dissolution process will increase. The rate of dissolution process will increase and the solubility of solute in the solution will also increase. So therefore we have observed two factors, that is nature of solute and solvent, after that temperature, and the third factor is pressure. Okay, third factor is pressure, and in this case pressure has no effect because solids are incompressible. We cannot compress the solids. So therefore pressure has no effect on solubility of solid in liquid. So in this class we have learned about what is solubility, after that factors affecting solubility, and then we have learned about solubility of solid in liquid. So that means we have learned about crystallization, dissolution, saturated solution and dynamic equilibrium, and then we have briefly described how those factors, that is temperature, pressure and nature of solute and solvent, affect on solubility of solid in liquid. Okay, thank you.